transfer, we're going to discuss energy associated with the physical changes. We should understand that heat is involved in physical changes. We should be able to interpret a heating curve and also be able to tell melting and boiling points from that heating curve. So here's a simulation that we tried to do a little while ago that didn't work. And what a key thing is that the melting point and boiling point, or melting point and freezing points, are the same. It's the same temperature, whether you're adding energy or removing energy. So for instance, the melting point of water is 0 Celsius. So if I have ice at 0 Celsius and it heats up, it turns into a liquid. If I have liquid at 0 degrees Celsius and I remove energy, I cool it down, it turns to a solid. But it happens at that same temperature. And that's a very big thing. In fact, I was watching the Cosmos the other day, and they were talking about the moon called Titan, which is a moon of Saturn. And interestingly enough, Saturn, that moon is a lot colder than it is on Earth. And in fact, it's cold enough so that methane, the same methane, natural gas, that heats up your house and we get out of the methane jets, that's a liquid on that planet. Because the boiling point of methane is below the temperature that the moon is. Does that make sense? Okay. So the moon's temperature is below the boiling point of methane. So you have liquid methane. So that's why they actually have seas. They have lakes and streams of methane liquid there. So it's an interesting fact. Water boils at 100 degrees Celsius if it's heating, and it condenses at 100 degrees Celsius when it's cooling. So, energy changes. Now, leave a little bit of space here. I'm going to give a couple key points. Kinetic energy relates to temperature. Right? That's something we talked about before. So if my temperature changes, my kinetic energy changes. And that's when the particles move faster or slower. Remember that simulation we did with Mr. Costa the other day? Potential energy relates to phase. Or the position of the particles. So if we change the phase, we change the potential energy. I like this one, the potential energy, because it's all the P's. The potential energy, phase is a P word, potential, particle, position. It's all the P's right there. And in fact, another P, plateau. So that's when we see a plateau in the heating curve. So a plateau is a flat area. So here we have our heating curve. And you guys have a sketch of this here. So when temperature's changing, our kinetic energy is changing. So between what's happening in these different regions? Let's take a look at this. So from A to B, what changes? Temperature changes. From A to B, my kinetic energy changes. My kinetic energy increases. If I'm heating it up, it decreases if I'm cooling it down. What phase am I here? Below 0 Celsius, what phase is water?
Freezing.
What is it, Ryan? Below here, it's a solid. Ice is a solid. So my potential energy is constant. let's just say from B to C, what happens here? What's going on here? What's happening to my temperature?
It's the same thing.
What's the same?
The temperature.
Temperature is constant. What's happening to my potential energy? What's happening to my phase? My phase is changing. From C to D, what's going on there?
Temperature's rising.
Temperature is increasing. My kinetic energy is increasing, is changing. What's happening to my phase? What phase is H2O between 0 and 100 Celsius? Liquid. So my potential energy is staying the same. Okay? Almost there. D to E. What's happening to D to E? What's happening to my temperature?
Constant.
Temperature's constant. My kinetic energy is constant. My potential energy changes. I'm going from a liquid to a gas, or gas to a liquid.
Condensing.
Yep. So if I'm going this way, I'm talking about boiling or vaporization. This way, I'm talking about condensation. Right? So if I'm heating up, if I'm going this way, I'm boiling, I'm increasing my potential energy. If I'm going this way, I'm cooling down, I'm talking about decreasing potential energy. And lastly, E to F. What's going on there? What's happening from E until you get to something crazy? What's changing there?
It's rising. The temperature's rising.
Temperature's rising, kinetic energy increases,
It's melting.
or kinetic energy is changing.
No, not melting.
Potential energy, constant. Okay? Does that make sense?
Yeah.
Good. So, if you're looking at this substance here, why don't you guys take a quick look? It's similar to the warm-up, but let's answer this real quick. What's happening? What's the melting point here? Rami? Yep. Melting point. And what's the boiling point here?
Almost 3.
What do you say?
23, 24.
Let's say, no, it's above 25. That's 25. So probably like 2,800. Now, a couple key things. Notice how much longer it takes to melt than it takes to boil. Interesting fact, it takes a lot more energy. More energy to boil than melt. So it takes, let's think about this as energy right here. This axis. So it takes a small amount, it takes a little bit of energy to melt it. It takes a lot of bit of energy to boil it up because you're really separating those particles a lot more. All right, so that should be it for notes today. We're going to work on this tomorrow. And that's it. Let's